naman yung ating ano doon. So, dito sa ating attendance, now we are at 22, 21. Hindi ako kasama. Ito, may isa pang i-admit. Okay, 23. Right. O, ayan na. Sige na, kayo na bahala. You may now start sharing. Okay. Magle-less ako ng video para hindi ako ay naririnig. Saan yung video? Yung camera. Ayan. Okay, good.
Kita po, ma'am.
Yes, kita.
So, ayun. Good morning, everyone. So, before tayo mag-start, may icebreaker kaming hinanda. Ano siya? Mala 4 picks, 1 words na style. Wherein, mapuform mo yung words sa images mismo. So, ayun. Base na lang po yung... So, number 1. So, yes, Paolo.
Induction.
Check. Correct. Yay. Correct. So, number 2. So, tama po si Paolo. Number 2. Sirat na ba, guys?
Ordering.
Correct. Okay. Let's check. Tama po si Dilian. And next. So, ayun. Sirat na, guys.
Parang hirap na hirap sila. Wala sumasagot ah. Maganda yan ah. Maghanap na ako ng ganyan.
May Gcash daw po kay Steve ang makahula. So, ayun, sirit na, guys. Strong induction. So, move tayo sa next. Yes po, Miss Rochelle and the driver.
Basis step.
Correct. Thank you. Next. Yes po, and.
Recursion.
Yes, correct. Next. So, ayun. Rewrite step according to Paolo. I press. Repen step. Step up notes kay.
Recursive step.
Correct. Next.
Algorithm.
Correct. Next. Ay. Napindot ko. So, ayun, next. Next na tayo.
Recursive algorithm.
Recursive algorithm.
Correct. Next. So, last na to, guys.
Pi Fibonacci sequence.
Correct. So, ayun. Proceed na tayo, guys. Slide. So, ayun guys. Yung in-icebreaker natin is related sa magiging report namin, which is induction and recursion. So, good morning everyone. My name is Annalyn Dalan and I will be your presenter for this topic. So, the topic that we will be discussing are all about mathematical induction, strong induction and well-ordering, recursive definitions and structural induction, recursive algorithm, and program correctness. So, let's start first with mathematical induction. So, mathematical induction is a technique that can be applied to prove the universal statements for sets of positive integers or their associated sequences. So, generally, ang method na ito is used to prove if the statement or theorem is true for all natural numbers. So, the history of mathematical induction. So, the first known use of mathematical induction is in the work of the 16th century mathematician Francisco Morelico. So, ito po si Francisco Morelico. So, Morelico wrote extensively on the works of classical mathematics and made many contributions to geometry and optics. In his book, Arithmeticorum Libre Duo, Morelico presented a variety of properties of the integers together with proofs of these properties to prove some of these properties. He devised the method of mathematical induction. His first use of mathematical induction in this book was to prove that the sum of the first n odd number positive integers is equals to n squared. So Augustus de Morgan is credited with the first presentation in 1838 of formal proofs using the mathematical induction, as well as introducing the terminology mathematical induction. Morelico's proofs were informal and he never used the word induction. So the principle of mathematical induction is to prove that P of n is true for all positive integers n, where P of n is a propositional function, and with that, we also need to complete two steps. First is the basis step, which we need to verify that P of 1 is true, and the inductive step, which we need to show that the foundational statement of P of k implies that P of k plus 1 is true for all positive integers k. So, as an example, I've provided here a video of a domino effect. So, ayun guys. Ang magiging basis step natin doon is yung unang domino na natumpa. So, our P of n, let P of n be the proposition that domino n is not over. So, if natumpa yung unang domino, therefore, we already proved that P of 1 is true. So, if natumba siya, therefore, yung susunod sa kanya is also matutumba. With that, we also proved that k of 1's domino over. So, if P of k implies that P of k plus 1 is true for all positive integers, therefore, lahat ng domino is matutumba.
Ayoko na, ako'y maglalaba. Hindi ako makikipag-laro sa'yo.
So, another example is here for mathematical induction. So, we need to prove that 1 plus 2 plus 3 plus n is equal to n times the quantity of n plus 1 over 2. So, our first n is equal to 1. So, bakit ito nag-1? Kasi yung first term natin is 1. So, therefore, 1 siya. So, all we have to do now is to substitute 1 sa n dito. Kaya siya nag-result here. So, ayun, by doing that, we will come up with 1 times 1 plus 1 over 2. So, 1 plus 1 that is equals to 2 times 1 that is 2 divided by 2 that is equal to 1. So, with that, we already proved that this is correct. So, we might ask ourselves, paano kapag 2 terms na? So, kapag 2 terms na guys, all we have to do is to add this. Kaya siya nag-result sa 3 here. So now, doing the previous step, all we have to do is to substitute 2. Bakit 2? Kasi 1, susunod 2. So therefore, 3 siya. So ayun, all we have to do is to substitute 2 sa lahat ng n dito. So ayun, with that, we will result to 2 times the quantity of 2 plus 1 over 2. So 2 plus 1 that is equals to 3 times 2. Which is 6 divided by 2 that is equals to 3. So we also proved that this is correct. So next, what if pag 3 terms na? So all we have to do is to add this. So 1 plus 2 plus 3 that is equals to 6. Kaya siya 6 dito. So ang magiging n na natin is 3. So ayun, doing the same process, all we have to do is to substitute 3 sa lahat ng n dito. By doing that, we will solve with 3 times 3 plus 1 over 2. That is equals to 3 times 4, kasi 3 plus 1, that is 4, which is 4. So 4 times 3, that is equals to 12, divided by 2, that is equals to 6. So we also prove that this is correct. So what if naman kapag 15th term, or 38, or 10, paano natin mapuprove it is correct siya? So, papasok si induction step. Kay induction step, okay lang mag-assume. So here, we have to assume that our statement 1 plus 2 plus 3 plus the arbitrary of plus k is equals to k times k plus 1 over 2. So here, we need to show that for all natural numbers of k, plus 1 is true. So all we have to do is to substitute k plus 1 sa lahat ng magiging k dito. Kaya magiging 1 plus 2 plus 3 plus the arbitrary plus k plus 1, that is equals to k plus 1 times 3 plus 1 plus 1. So, dinikit ko na yung 1 dito kasi i-add lang naman siya. Hindi natin kahirapan. Over 2. So, ayun. So, k, hindi ko na to sinama kasi we already proved that that is true dito. So, focus na lang tayo dito sa next. So, k times k plus 1 over 2 plus k plus 1 is equals to k plus 1 times k plus 2 over 2. So, k plus 2 kasi inad na natin to. So, here you might ask, bakit may 2 na dito? Ay, wala naman dito. Nilagyan ko na siya, guys. Kasi 2 divided by 2 is 1. So, wala namang effect. Para mag-focus na lang tayo sa numerator. Since pare-pareho lang naman yung denominator niya. So, rewrite natin siya. That will result to k times k plus 1 plus 2 times k plus 1 is equal to k plus 1 times k plus 2. So, k times k, that is equals to k squared. K plus 1, that is equal to k, and 2 times k, that is equals to 2k, plus 2 times 1, that is equals to 2. So here, all we have to do is to use FOIL method. Kaya, k squared times 2 plus 2k plus k plus 2. So with that, we already proved that our induction step is also true. Now, going back to our presentation, so going back to our presentation, so now, balik tayo sa another topic, which is strong induction and well ordering. So, si strong induction, para lang siyang si mathematical induction, pero in a more precise or concise way siya. So, strong induction is sometimes called the second principle of mathematical induction or complete induction. So, when the terminology complete induction is used, the principle of mathematical induction is called incomplete induction. A technical term that is somewhat unfortunate choice because there is nothing incomplete about the principle of mathematical induction. So, if merong principle si mathematical induction, si strong induction is meron din. So, si strong induction, we need to prove that P of n is true for all positive integers n, where P of n is a propositional function. And with that, we also need to complete 2 steps. The basic step, which we need to verify that the proposition of P of 1 is true. And the inductive step, which we need to show the conditional statement of P of 1 and P of 2, and the arbitrary of P of k implies that P of k plus 1 is true for all positive integers k. So, example of that is here. Yung pag-akyat sa hagdan. So, imagine, our basic step here is that we already verify na kaya natin umakyat sa first rung. And with that, repeating the process, we will also prove that if we can reach the first rung, therefore we can reach also the second rung and the next rung. So here, the basic step is the same as before. It simply verifies that we can reach the first rung. And the inductive step would be that the hypothesis states that if we can reach the first rung, to complete the inductive step, we need to assume that the inductive hypothesis is true. So if we can reach the first rung, then we can reach the next rung. So we already know that we can reach the second rung. So if we complete the inductive step by noticing that as long as k is greater than or equal to 2, we can reach the k plus 1 rung. From the k plus minus first rung, because we know that we can climb 2 rungs from a rung, we can already reach, and because k minus 1 is less than or equal to k, by the inductive hypothesis, we can reach that k minus 1 rung So we already proved that our inductive step is true. So again, we have proved that if we can reach the first 2 rungs of an infinite ladder, and for every positive integer k, if we can reach all the k rungs, then we can reach the next rung. Ganun lang siya. Para siyang yung domino na kapag natumba yung isa, therefore, natumba rin siya. So, ayun. Another example is here. Show that if n is an integer greater than 1, then n can be written as the product of primes. Our solution is that let P of n be the proposition that can be written as the product of primes. So our basic step will be that P of 2 is true because 2 can be written as the product of prime itself. And our inductive step will be that the assumption of P of j is true for all integers j with 2 less than or equal to j less than or equal to k. So the assumption that j can be written as the product of primes whenever j is a positive integer, at least 2 and not exceeding k. So to complete the inductive step, it must show that P of k plus 1 is true under this assumption, that k plus 1 is the product of primes. So with that, we need to consider 2 cases. When k plus 1 is prime and when k plus 1 is composite. So if k plus 1 is prime, we immediately see that P of k plus 1 is true. Otherwise, k plus 1 is composite and can be written as the product of 2 positive integers a and b with 2 less than or equal to a, less than or equal to b, less than or less than k plus 1. So because we both a and b are integers at least 2 and not exceeding k, we can use the inductive hypothesis to write both a and b as the product of primes. Thus, if k plus 1 is composite, it can be written as the product of primes, namely those primes in the factorization of a and those in the factorization of b. So going back to our slide, we'll now come to the well ordering property. So here, si well ordering property, all we have to remember is yung non-empty set of non-negative integers is dapat may matitirang or merong least element. So example of that is here. Wait. So here we have an example. Set S is equal to set of all elements of the form 2k plus 1 such that k is an integer with k greater than or equal to 0.
Later, probably no.
So Z represents the integer. So with that, all we have to do is to substitute a number by k. So let's assume that 2, for all the set of 2 times 0 plus 1, 2 times 1 plus 1, 2 times 2 plus 1, and 2 times 3 plus 1, and 2 times 4 plus 1, and so on. So 2 times 0, that is 0 plus 1, that is 1. So 2 times 1, that is 2 plus 1, that is equals to 3. So 2 times 2, that is equals to 4 plus 1, that is equals to 5. And 2 times 3, that is equals to 6 plus 1, that is equals to 7. And 2 times 4, that is equals to 8 plus 1, that is equal to 9. So here, we already have a least element of 1, 3, 5, 7, and 9. So S is the set of positive odd numbers. So with that, we already proved that our smallest element is 1. So moving forward with our next.
Hello? Narinig ba ako?
Yes po.
Okay, let's proceed now to recursive definitions. Next slide, please. Okay, recursive function is one that generates a series of terms by repeating or using its own prior terms as input. In most cases, we learn about this function via the arithmetic geometric sequence, which has terms with a shared difference. So, itong recursive function ito parang parehas lang sa induction in the terms of paulit-ulit yung function na gagamitin. At with this one, magsisimula tayo from the main function. Pag malaki yung number, yung equation na gagamitin sa equation or function or sa program ay paliit ng paliit. So for better understanding, let's proceed to elaborating this subject. Next slide, please. Okay. So let's start first with the history of recursion. The use of recursion goes back to the 19th century. Dedekind in 1888 used the notion to obtain function needed in his formal analysis of the concept of natural number. In logic, recursion appears in Descolem as a person from 1923. Theory of recursive functions was developed by the 20th century Norwegian Torop Albert Skolem, pioneer in metalogic, as a means of avoiding the so-called paradoxes of the infinite that arise in certain contexts when all is applied to functions that range over infinite classes. It does so by specifying the range of a function without any reference to infinite classes of entities. So ang nakikita natin dito na goes back to 19th century yung the use of this recursive function because of how useful it is, and so that it says here that Skolem he used this recursive function so that the paradoxes of infinite is applied to all functions that range over infinite classes, so that we can use an equation or function so that we can clearly state something that we think is infinite. Okay, next slide please. Ayan, makikita natin si Richard Dedekind on the left side and Torop Skolem on the right side. Yeah. So let's elaborate the meaning of recursion. So what is recursion? To put it simply, recursion can be intuitively illustrated by taking some familiar concept such as human, or the function x is human. So let's give you an example, a brief example for layman's term of recursion. Instead of defining this concept or function by its qualities and dispositions, one might say Adam and Eve are human. So let's say that all people started with Adam and Eve, and any of the offspring of theirs is human, and any offspring of their offspring is human. Here, two values of the function x is human are mentioned, and the relationship in which they stand to other entities is given. Through this relationship, all things that are values of x is human are selected by a back reference or recursion by many steps to Adam and Eve. So let's say, for example, we as humans, galing tayo kay Adam and Eve. So we can use ourselves as a definition of recursion by tracing back to who started it all, to Adam and Eve. So parang yung magiging logic dito, tayo yung magiging number in, let's say, number 300 tayo sa line ni Adam and Eve, and we can trace it all back to Adam and Eve so that it will not cause confusion to where all those numbers began. Okay, next slide please.
Okay, dagdagan ko lang yung ano niya, no? So, yung recursion, it works as a lineage, no? So, halimbawa, ano tong pangalan niya, no? Sino yung nagre-report? Si...
A person to.
Yes. So, yung family mo, kung ano yung, ito yung magandang application ng ano ng recursion, if you're familiar with yung ancestry.com, it will look for your lineage. Although sa ano kasi sa US, yung hinahanap nilang lineage, it's not more on the surname but on the ano, yung pagiging ano, 'di ba? Hindi ko alam kung sino nakapag-ano na sa inyo ng yung sa mga DNA, pero genetic yun eh. Hindi. Iba yung sa genetic, iba yung sa ancestry. Sa ancestry is more on ano eh, looking at yung ano ng race, no? Yung trace, i-trace back yung ano ng lineage ng kanilang race. So it works like that, no? So merong ang concept dito is saan nagmula at matitrace ba yung pinagmulan, pang ilan ka ba, no? Pang ilang generation halimbawa dun sa lineage, no? So maganda yung example nila. So please appreciate yung example ng group. Okay, thank you. Continue.
Okay, thank you po ma'am sa elaboration. So yun nga, tulad nung like what Ma'am Angie said, that we can trace this back as a lineage so that we can see that recursion also, and also induction as real life uses. So next slide please. The recursiveness in a function or concept is closely related to the procedure known as mathematical induction, just as I have said, and is mainly of importance in logic and mathematics. For example, so let's say X is a formula of logical system L. So or X is a natural number, let's say. To say simply, kahit anong number, basta positive, use natin ang example, is frequently defined recursively. These functions are correlated with purely routine operations that may be repeatedly applied to given formulas or numbers, eventually relating them to certain listed values of the function. Examples given to P and Q as one formula or to 0 as one natural number, thus avoiding functions that range over infinite classes with the risk of incurring paradox. So, what I'm saying here, tulad ng sinabi ko, we can trace back the numbers that was originally formed through an equation or a function. Let's say sa factorials, we can trace back the number to its origins. to to re- to reduce the risk of infinite classes. And next slide, please. So, ayan, let's say, let's use the Fibonacci sequence as an example. So, in mathematics, things are often defined recursively. For example, the Fibonacci numbers are often defined recursively. The Fibonacci numbers are defined as the sequence beginning with two ones, and where each succeeding number in sequence is the sum of the two preceding numbers. So as we all know, Fibonacci sequence, we have studied it in the past, we have studied it as far as elementary. It's the addition of the two beginning numbers, and it grows bigger and bigger as it goes by. So it starts with 1 and 1. 1 plus 1 is 2. Yun yung sunod niya. Then 1 plus 2 is 3. Then so on and so forth. Mag-add lang no number before the preceding number. Next slide, please. So yan, katulad nga ng sinabi ko, makikita natin sa pinaka in the uppermost part of the page yung Fibonacci numbers. We obtained 8 in the above sequence by summing the previous two numbers, 3 and 5. So yan, let's use the numbers 3 and 5 as an example. A formal mathematical definition would define this using mathematical symbols. So medyo nagulo lang yung type, pero ang ibig sabihin niyan, the function of n, yung n is any numbers from the Fibonacci sequence. 1 yung sagot if n is equals to 0 or n is equals to 1. So, i-explain ko yun mamaya kung bakit maging ganyan. And also, f, ito yung magiging function natin para magkaroon ng lineage sa recursive function natin para ma-trace back natin yung original numbers. F, open close parenthesis, is the function of n minus 1 plus f, the function of n minus 2 otherwise. So this makes the recursiveness of the definition obvious. Notice how we've defined function n in terms of function, namely f function n minus 1 plus f function n minus 2. Incidentally, such recursive definitions of functions are called recurrences. Next slide, please. Okay, please return to the other slide. Explain ko lang muna. So then, dito makikita natin sa Fibonacci sequence na ginamit itong imbes na to trace back numbers, we would need to manually deduct the numbers one by one. That's a long process. That's a hard process. That's why we don't want to proceed with that. That's why we use the recursive function so that we can base a function by defining it as an equation so that we can easily trace back the origin of numbers. So let's say in 1, if n is equal to 0 or n is equals to 1. Why is that? Kasi pag let's use the function below, f, the function n minus 1 and plus f function n minus 2. Let's use 1 as a number. So if f, we replace the n with 1, 1 minus 1 is 0, and 1 minus 2 is negative. So it would ruin the lineage. That's why we do need to we do need to modify this function by opposing other numbers. Like if we find that some numbers may oppose to the lineage, we may set them aside, and but only a few numbers can be set aside, not all, like 0 or 1 in this case. So for this one, let's use a different example. Let's use 3. 3 is an example of function n, so that we can trace back 3 to its origins. So if we use f and we replace the n with 3 minus 1, that is 2, and function of n, we replace it with 3 also, minus 2 is equals to 1. So 2 plus 1 is equals to 3. We can trace it back to the Fibonacci numbers. That is called also recurrences, just as stated. Okay, next slide. And then we go to the recursive algorithm. So in this recursive algorithm, we can now apply this to the programs, the codes. A recursive algorithm is an algorithm which calls itself with smaller or simpler input values and which obtains the result for the current input by applying simple operations to the returned value for the smaller or simpler input. More generally, if a problem can be solved utilizing solutions to smaller versions of the same problem, and the smaller versions reduced to easily solvable cases, then one can use a recursive algorithm to solve that problem. For example, the elements of a recursive algorithm, for example, the elements of a recursively defined set or the value of a recursively defined function can be obtained by a recursive algorithm. Okay, I'll explain this in the next slide because it's not really that hard. It's just that the definitions are long. Okay, next slide, please. So, for example, this is what we can use: algorithm for finding the k even natural number. Note that this can be solved very easily by simply outputting 2 times the function of k minus 1 for a given k. The purpose here, however, is to illustrate the basic idea of recursion rather than solving the problem. So, okay, in algorithm 1, you can input this in the system as even positive integer k, and the input will be k, a positive integer, and the output will be k, even natural number, the first even being 0. Then the algorithm would be, so just what I said in the past slides, like in the Fibonacci numbers, we remove sa a number, yung ibang number i-divide natin. Haalisin natin dun sa equation dahil katulad na sinabi ko, the numbers itself negate the rules of recursiveness, and thus it does not reflect the originate of the number. So let's use 1 as an example, then return to 0. Because 1 is a small number and thus it negates the rule of recursiveness. So we use 1 and we remove 1 from the equation, and thus it can return to 0. If else, return even k minus 1 plus 2. So in this one, what we can use is only the numbers 2 and above to represent the recursiveness of a function. Okay, next slide, please. Here, the computation of even k is reduced to that of even for a smaller input value, that is even k minus 1. even k eventually becomes even 1, which is 0 by the first line. For example, compute even 3, algorithm even k is called within k equals 2. In the computation of even 2, algorithm even k is called with k equals 1. Since even 1 equals 0, 0 is returned for the computation of even 2, and even 2 is equals to even 1. Plus 2 is equals to 2 is obtained. This value 2 for even 2 is now returned to computation of even 3. And even 3 is equals to even 2 plus 2 equals 4 is obtained. So what I'm saying here is if we use the numbers above 1, let's say 3 given here, and in the computation it is minus 1, so it is equals to 2 plus 2, and it equals and then 4 is obtained by that. So in the recursiveness, we trace back the origin of the numbers, and we can see that 2 here, if we use it as the next equation to the lineage, then 2 minus 1 is equals to 1. 1 plus 2 is equals to 3. Then 3, we can use it as a lineage also. 3 minus 2 is 1, and for 1 we return to 0. That's when the computation will stop. Okay, next slide please. As can be seen by comparing this algorithm with the recursive definition of the set of non-negative even numbers, the first line of the algorithm corresponds to the basis clause of the definition. The second line responds to the inductive clause. By way of comparison, let us see how the same problem can be solved in an iterative algorithm. So what this means, what this slide means simply is that an iterative algorithm is the one that repeats. So it's like if we input this in the program, it can help the code by only inputting the function, so that we will not input the equations repeatedly. So that in recursive function, we can now use this in the program just once, and we don't want to repeat other equations so that we can solve for a number. Okay, next slide please. So for an example again, so that we can clarify this in algorithm 2, is factorials. So in factorials, 2 exclamation mark is equals to 2 times 1 simply, and 3 exclamation mark is 3 times 2 times 1. Yes, that will be the factorial of 3. And 4 exclamation mark 4 times 3 times 2 times 1. So to put simply, that is the factorials. And we can use this also as an algorithm so that we can find its recursiveness. So the function of n exclamation mark is equals to n times n minus 1 factorial if n is greater than or equals to 1. So there's a distinction in other numbers. Otherwise, if n is equals to 0, then return to 1 or 0. As we can see here, as in a recursive function, there's a distinction between 0 and positive numbers, because in 0 it negates the rule of recursiveness, so that's why we separate it with the other numbers. So in algorithm, we can use this in the code as int of n fact as in factorial. If n is greater than or equals to 1, then return n times factorial, n is minus 1. Else, return to 1. So, nakita natin dito na ginamit yung factorial as a way of coding. So, if n is equal to 0, that is the else return to 1. And if n is greater than or equals to 1, return to n times factorial n minus 1. So for example, 5 factorial yung number. And we can replace n with 5. So 5 times 5 minus 1 factorial is, let's first solve for the one in parentheses. So 5 minus 1 is equals to 4. 4 factorial. So in 4 factorial, and there is 4 times 3 times 2 times 1. So 4 times those numbers, we can trace back the numbers of 4 factorial to the other factorials, because in this one, let's say 4 times 1 is, 3 factorial pala. 3 factorial pala yan. Then in 3 factorial, we can also recursively use this function, and 3 minus 1 is 2 factorial, and until it reaches the 1, which will return it to the original function, which is 0. Next slide, please. So in program correctness, as we can see here in program correctness, we will see here the codes of which we use these numbers. This is how we will check that what we inputted in the codes are correct. Okay, next slide, please. To prove the correctness of a recursive algorithm, we use mathematical induction. In the mathematical induction, we want to prove a statement p function of n for all natural numbers n, possibly starting at an n0. But let's assume for simplicity, we are providing the statement for all n greater than or equal to 1. Okay, next slide, please. In an induction, we apply typically to prove this by 1, proving p of n for a base case, sometimes several base cases, examples that to prove that p of 1 holds, and then providing that if p of n holds for some n, that is the induction hypothesis that p then holds for the next natural number, like p n plus 1 holds. So in that case, we can see that what Annalyn had discussed in the past slides, how we can how we can see the correctness in those numbers, and she proved it on the examples that she had provided. And now for recursion, it's also the same. They are closely related, the induction and recursiveness, because they both follow a specific function or equation that will prove something is correct. So in recursiveness, it also follows this rule in program correctness, that if something fails to follow, to follow the rules of recursiveness in induction and fails to follow up the lineage, then it is not correct in a program, and it will cause an error. Okay, that will be all. Thank you very much for listening.
Okay. Ito na ba yung last na reporter or may kasunod pa doon sa group?
May kasunod to po, ma'am.
Okay. Sige.
Hello? Dinig po ba?
Yes, dinig po.
So, hello and good morning everyone. Now that the first half of our group has finished discussing the chapter 5, the induction and recursion, we will now proceed with the chapter 6, which is all about counting. Next po. Before we proceed with the discussion proper, we will first have the icebreaker that we prepared. So, if anyone wants to answer po, please raise your hand lang. Next. For the first part, the instruction is to guess how many possible sequences can be made with the given objects. So, ang given is the letters A, B, and C. So, ilan daw yung possible sequences magagawa natin with that? Sino pong gusto sumagot? So, madali lang yan, guys.
6.
A, B, and C.
Dami. 6.
Sabihin nyo lang guys kung ilang sequence yung possible. Kahit hindi nyo na i-enumerate kung ano yung mga sequences na number. Anyone? Wala pong bang sasagot?
27. Ang gulo ni Ma'am Pay, nakikigulo.
Sige na nga, bigyan na natin tong first question. Paki-reveal po yung answer. So, ayan. Based dyan, 6 daw yung possible sequences with the letters A, B, and C.
Tama pala ako,
Ayun
6 yung unang sagot ko kanina.
Yes po.
In-exponent ko lang
Next.
yung last na Siguro sa number pwede. Oo. Yeah, correct.
Oh, ayun naman. For the second question, the given is W, X, Y, and Z. Ilan yung possible sequences na magagawa natin with that? Anyone?
$24.
Yes, tama. Paki-reveal po yung answer. Ayun. Ayun nga, tama. 24 yung possible sequences na magagawa natin. Next. So, the given is the colors blue, red, and yellow. Ilan pa yung possible sequences dyan?
Six din ba?
Yes. Tama. Paki-reveal naman po. Next.
Hindi lumilitaw?
Ay, hindi. Ano din, nakita ba?
Hindi. Balik.
Paki-balik po.
Ayun.
Ayan, yung mga possible sequences. So, yun nga. 6 yung answer. Next po.
Okay, so bago mo ibigay yung next, sandali lang, no? Since we are already delving into algorithms and cryptography, no? So, para ready yung ating mga brains, no? Gayon din naman ang ginagawa ko, kaya nagbibigay ako sa inyo ng yung mga riddles, mga brain teasers, kasi when we talk of algorithms and as well as to nga sa discrete structure, medyo minsan nakakalito, no? I think yung iba nakaka-relate dun sa ano na yun, kasi we're talking about algorithms. No, para maging ready yung brains natin, ayan, binibigyan namin kayo katulad nitong groups na nagpe-present ng mga ganito to prepare our brains. And also, so parang hindi tayo masyadong malito dito sa ating inaaral. Siguro i-prepare na natin since nagbibigay sila ng mga ganitong sequence ganon, no? In order for us to appreciate, no? Appreciate algorithms, data structure. Ito po yung lagi natin titingnan. Always look for the pattern. Ayan. Kasi yung pattern, yan po yung pinaka ng algorithm, ng data structure. Nag-i-establish siya ng pattern. So, pag nakita niyo yung pattern, mas lalo niyo itong maiintindihan. Ayan. Okay. Sige po, diretso.
Okay po. Sa second part naman tayo. The instruction is, guess which possible sequence is missing from the following. So, dito naman, we have 5 given ng possible sequences. And hanapin nyo kung ano yung nawawala. Ano yung pang 6? Anyone would like to answer?
Si Joshua, nagtaas.
Ayun. Yes, Joshua?
PAC.
Tignan natin kung ano yung answer. Paki-reveal po.
PAC.
Ayun, tama. BAC. Next question. Ayun. Ganun pa rin yung gagawin. Hanapin niyo lang kung ano yung nawawalang sequence. We have the colors red, yellow.
Tinanggal niya na. Okay.
Anyone?
So, look for the pattern. Wala pa nagtatas ng kamay. Ayan, may nagtatas na ng kamay.
Yes, Mark Vincent. Yung answer. Ano po ulit?
Yellow, red, blue.
Okay, tingnan natin yung answer. Paki-next po.
Correct.
Ayun, tap. Yellow, red, blue. Next tayo. So, for the third part, the instruction is to enumerate all of the possible sequences based on the given objects. Ang given objects natin for this is the sun, cloud, and lightning. So, sino po pwede mag-enumerate ng mga possible sequences dito? Ay, ayun pala. May nag-raise na. Yes, si Adrian.
Narinig ano?
Yes, rinig.
And yung first is sun, cloud, thunder. Then second, sun, thunder, cloud. Then yung third is cloud, sun, thunder. Then yung fourth is cloud, thunder, sun. Then fifth is thunder, sun, cloud. Then yung sixth is thunder, cloud, and sun. Ayun, 6 na possible sequences.
Okay. Tingnan natin po yung answers. Ayun. Connect ko and nabanggit niya naman lahat. Thank you. Next po tayo.
May points yung mga nagpa-participate, ha?
Let's
Yan,
go.
ha? Akakala nyo walang points. May points yan.
For this naman, apat yung given natin, which is the numbers 1, 2, 3, and 4. But medyo mahirap pa ito. Who would like to answer? We have,
So, number naman yung sequence nila.
Apo. Ano to? 24 sequences. Medyo mahirap ba? Bigay ko na lang yung answers. Walang sasagot. Ay,
Ayan.
meron. Yes, Joshua?
Ayun, 1, 2, 3, 4, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, 1, 4, 3, 2. So, 6 na yun. Next, 2, 1, 3, 4, 2, 1, 4, 3, 2, 3, 1, 4, 2, 3, 4, 1, 2, 4, 1, 3, 2, 4, 3, 1. Next naman, so 12 na yun. Next is 3, 1, 2, 4, 3, 1, 4, 2, 3, 2, 1, 4, 3, 2, 4, 1, 3, 4, 1, 2, and 3, 4, 2, 1. Lastly is 4, 1, 2, 3, 4, 4, 1, 3, 2, then 4, 2, 1, 3, 4, 3, 4, 2, 3, 1, tapos 4, 3, 2, 1, tsaka 4, 3, 1, 2.
Ayun. Tingnan natin kung nabanggit niya lahat. Ayun. Tama. Nabanggit niya naman lahat ng 24 answers. Ayun.
He started with a set of ones, and then a set of twos, a set of threes, and a set of fours, no? So, like I said, yung pagdating dito, no? Always look for the pattern. Pag na-establish niyo yung pattern, madali na siyang masimulan, no? Ayan. Okay, continue.
Ayun po. With that, tapos na po yung icebreaker namin. So, we will now proceed with the discussion proper. Here we have the contents, starting from the introduction. 6.1, the basics of counting. 6.2, the pigeonhole principle. 6.3, permutations and combinations. 6.4, binomial coefficients and identities. 6.5, generalized permutations and combinations. 6.6, generating permutations and combinations. Next. So, for the introduction, we will first look at some definition of terms. Next. First term is combinatorics. It is the study of arrangement of objects. It is an important part of discrete mathematics. It was studied long ago as the 17th century. It involves generating all the arrangements of a specified kind, which is important in computer simulations. So, yun po. dating-dati pa is meron ng combinatorics. Siguro may nakita silang mga scriptures na nagpapatunay dun pa. Next, we have counting. So, according to Merriam-Webster Dictionary, it is the process of determining the number of people, objects, etc. in a certain group. According naman sa Cambridge Dictionary, it is to indicate the number of units or groups so as to find the total number of units involved. Basically, pareho lang naman yung sinasabi ng dalawang dictionaries na yun. Counting is identifying the number of objects in a certain group. Also, counting must be used to solve many different types of problems, lalo na sa daily life. Kita-kita natin, kunwari, bibilangan natin yung pera natin, tapos magbabayad tayo sa kung saan-saan, kunwari sa mga tindahan, sa jeep, gano'n, pamasahe. Ayan. Aside from that, you can also use counting in the related profession sa course natin. Counting is used to determine the complexity of algorithms. Also, it is used when probabilities of events are computed. Yun po. Next. So with that, proceed na tayo sa chapter 6.1, which is the basics of counting. Next po. Basahin muna natin itong statement na to. Counting problems arise throughout mathematics and computer science. Masasabi po kasi natin na mathematics is one of the foundations of computer science. And under ng mathematics, we have counting. Yan. Ganun pala. Next. We have the basic counting principles. So these basic counting principles we can apply in many different counting problems and situations. The first one is the product rule. Suppose that a procedure can be broken down into a sequence of two tasks. If there are n sub 1 ways to do the first task, and for each of these ways of doing the first task, there are n sub 2 ways to do the second task, then there are n sub 1 and sub 2 ways to do the procedure. Para mas maintindihan natin, tingnan natin yung examples sa next slide. Ayan. So, number 1, a new company with just 2 employees, Sanchez and Patel, rents a floor of a building with 12 offices. How many ways are there to assign different offices to these 2 employees? So, imagine natin na yung isang floor ay may 12 offices. Pag inassign natin yung first employee na si Sanchez, ibig sabihin, ang matitirang offices na lang kay Patel is yung 11 na lang. Hence, the solution should be 12 times 11 is equal to 132 ways to assign offices to these 2 employees. Number 2, how many different license plates can be made if each plate contains a sequence of 3 uppercase English letters followed by 3 digits, and no sequences of letters are prohibited, even if they are obscene. So since we have 26 letters in the English alphabet, we will multiply 26 3 times yun. 26 times 26 times 26. Then, follow yun ng 3 digits, which can be from 0 to 9. That's why we multiply 10 times 10 times 10, resulting to 17,576,000 possible license plates. Yan. Basically, yung product rule, ang gagawin lang is ipag-multiply mga possible na objects na gagamitin. Ganun. Next, we have the sum rule where it states that if a task can be done either in one of n sub 1 ways or in one of n sub 2 ways, where none of the set of n sub 1 ways is the same as any of the set of n sub 2 ways, then there are n sub 1 plus n sub 2 ways to do the task. Para mas maintindihan ulit, tingnan natin yung mga examples. Yan. Sa number 1, Suppose that either a member of the mathematics faculty or a student who is a mathematics major is chosen as a representative to a university committee. How many different choices are there for this representative if there are 37 members of the mathematics faculty and 83 mathematics majors and no one is both a faculty member and a student? With this type of problem po, ipagko-combine lang natin yung dalawang given, which is yung 37 members ng faculty and 83 students na mathematics majors. Hence, the solution will be 37 plus 83 is equal to 120 possible ways to pick this representative. And number 2, a student can choose a computer project from one of the 3 lists. The 3 lists contain 23, 15, and 19 possible projects, respectively. No project is on more than one list. How many possible projects are there to choose from? So since pareho lang yung parang type of problem with number 1, pagko-combine lang natin lahat ng number ng possible projects na pwedeng gawin sa mga list na yun. So 23 plus 15 plus 19 is equal to 57 ways to choose a project. Yeah. Next, we have the subtraction rule. It states that if a task can be done in either n sub 1 ways or n sub 2 ways, then the number of ways to do the task is n sub 1 plus n sub 2 minus the number of ways to do the task that are common to the 2 different ways. The subtraction rule is also known as the principle of inclusion and exclusion. Next. Ayan. Basahin natin. How many bit strings of length 8 either start with a 1 bit or end with 2 bits 00? So for this question, may tatlong case kasi na pwede natin isagot. Either the byte, case 1 is that the byte starts with 1. Second case is that the byte ends with 2 zeros. The last case, the third case, is where the byte starts with 1 and ends with 0. So for the first case, since fixed na yung value nung first bit, ang natitira na lang sa atin is yung 7 bits dyan sa sa huli. Kaya ang solution po is 2 raised to 7. Then ang sagot is 128 ways. Pwede natin gawin. Yeah. For the second case, since fixed na po yung dalawang bits sa dulo, which is 00, 6 bits na lang po sa unahan yung pwede nating gawa ng possible sequence. Hence, the solution should be 2 raised to 6 is equal to 64 ways. Ayan. Lastly, pag fixed na po yung first bit natin, which is 1, then may dalawang 0 na sa dulo, 5 bits na lang po yung kulang. Kaya, ang gagawin is 2 raised to 5 is equal to 32 ways. Ayan. Kumbaga, hindi lang natin isasama sa pag-compute yung mga may value na natin. Ayan. Next. Okay. We have the division rule. There are n over d ways to do a task if it can be done using a procedure that can be carried out in n ways, and for every way w, exactly d of the n ways correspond to way w. Next. And examples ulit. Suppose that an automated system has been developed that counts the legs of cows in a pasture. Suppose that this system has determined that in a farmer's pasture there are exactly 572 legs. How many cows are there in this pasture, assuming that each cow has 4 legs and that there are no other animals present? So basically, ang gagawin lang natin is i-divide yung number ng legs by 4 since each cow has 4 legs. Ayun. Kaya ang lalabas po is 572 divided by 4 is equal to 143 cows. So with that, nabilang po nila yung cows. Yun. Number 2, how many different ways are there to seat 4 people around the circular table where 2 seatings are considered the same when each person has the same left neighbor and the same right neighbor? So that, kasi diba, ang solution dito is 4 factorial where 4 times 3 times 2 times 1. Kasi yun yung mga possible sequence. However, hindi po pwedeng same yung neighbor niya sa magkabilang side. Kaya i-divide po natin siya by 4, resulting to 6 different seating arrangements of 4 people around the circular table. Ayun po yung final answer. Next. Ayun. For the next one, we have 3 diagrams. Counting problems can be solved using 3 diagrams. It consists of a root, a number of branches leaving the root, and possible additional branches at the endpoints of the other branches. For examples, tingnan natin yung next slide. Ayan. Tingnan muna natin itong Morse code 3. Yung nakikita nating start dyan sa taas is yung root node. Then, yung mga branches niya, which is E and T, ayun yung mga other nodes. Then, sa ilalim nun, meron pang mag-extend pa sa ibang nodes like TAI, may A and A, and so on and so forth. Ayan. Dito naman sa second figure, tingnan natin. It shows the bit strings of length 4 without consecutive ones. Ibig sabihin, wala daw pong walang magkadikit na 1. Ganun. So, because of that, we have 8 possible combinations. Ayan. Ganun. It's a visual, as you can see po, 3 diagram is a visual representation of counting problems. Ayun. Next slide po. Okay. We're done with this chapter 6.2. We will proceed with the chapter 6. Tapos na pala tayo sa chapter 6.1 pala. Then, proceed na tayo sa chapter 6.2, which is about the pigeonhole principle. Next. So, in the pigeonhole principle, it states that if k is a positive integer and k plus 1 or more objects are placed into k boxes, then there is at least one box containing 2 or more of the objects. May pa-explain pa natin yan. It is also called the Dirichlet drawer principle after the 19th century German mathematician G. Lejeune Dirichlet. Next slide. So, sino nga ba si G. Lejeune Dirichlet? He is a German mathematician who often used the pigeonhole principle in his work. He was accomplished in the field of mathematics. Also, Dirichlet made many contributions to analysis. So, one way to describe him po is he loves mathematics daw, and he made many contributions in this subject. However, pabalik po. Pabalik po na slide. Yeah. However, he was not the first person to use this principle, which is the pigeonhole principle. A demonstration that there were at least 2 Parisians with the same number of hairs on their heads date back to the 17th century. Pinangalan po yung pigeonhole principle kay Dirichlet dahil ginamit niya sa ilang niyang mga works, pero hindi siya yung naunang gumamit nun. Actually, walang sinabi kung sino unang gumamit ng pigeonhole principle kasi malay natin, di ba? May mas nauna pa kaysa dun sa record ng 17th century. Ayun po. Yeah. Next.
Okay.
For the example, The given is we have 12 boxes and 13 pigeons. And yung pigeons po natin dito, i-consider natin as objects. Basic principle na yun. So, we can see three figures here, the A, B, and C. This shows the possible cases na pwede natin i-arrange yung pigeons sa loob ng mga boxes. For the first figure, the letter A, the second box have 3 pigeons, while the 9th box has 2 pigeons. This proves the pigeonhole principle too. Kasi may mga box po tayo na more than 1 yung pigeons na laman. Next tayo. Sa figure B. Ay, babalik po. Ayan. Sa figure B, we have 2 pigeons on the 4th box, which also still proves the pigeonhole principle. Ayan. Ganon din sa C, where the 3rd box has 3 pigeons, the 4th box has 2 pigeons, and the 7th box has 2 pigeons. Ayan po. Next. Aside from that, yung kanina, may mga iba pa pong situations na may apply natin yung pigeonhole principle. For example, so number 1, among 100 people, there are at least 9 who were born in the same month. Paano po nasabi yun? Ganito lang. Bale, i-divide natin yung number ng people, which is 100, by 12, which is the number of months. Kaya po, ang result is 8 point something. Then, ni-round up. There is at least 9 people who were born in the same month. Yan. Number 2, in any group of 27 English words, there must be at least 2 that begin with the same letter because there are 26 letters in the alphabet. And nga, kahit sa first 26 words mo na yan, kahit walang magkakapareho ng first letter, kapag may pinasabrahan kang isa, yun nga, kapag 27 na English words mo, guaranteed na yun na may 2 kang words na magkapareho ng first letter. Yan. Number 3, what is the minimum number of students required in a discrete mathematics class to be sure that at least 6 will receive the same grade if there are 5 possible grades, A, B, C, D, and F? So with that, since 5 po yung possible grades, we multiply 5 by 5. Pero, kulang pa po yun. Dapat, yun nga, may pasobrang isa para ma-ensure natin na at least 6 students will receive the same grade. Ayun. 5 times 5 plus 1 is equal to 26. 26 yung kailangan nating students. Ayun. Next. Next slide po. Ayun. So, ang generalized pigeonhole principle states that there must be at least 2 objects in the same box when there are more objects than boxes. Ayun nga po, gaya nung na-explain kanina. Kapag marami yung pigeons or yung objects kaysa sa box, guaranteed na may isang box na more than 1 yung object na laman. Ayun lang po yun. In support. Yan po. So, the next presenter will be John Nicolas. Please proceed na po sa next chapter. Thank you.
Hello, rinig po. Hello?
Yes, rinig.
Thank you. So, hi, this is John Nicolas B. Wondasan. Good morning to all. I'm going to present the permutation and combination, chapter 6.3. So, tapos na tayo sa counting. At, yun nga, bibilang pa rin tayo, syempre. So, permutation and combination. Alam ko, karamihan sa atin, meron ng background sa permutation and combination. So, ano nga ba uli yung permutation? Permutation, nakikita niyo po ba yung screen? Hello?
Yes.
Yes, kita.
No, thank you. So, ang permutation po is an act of arranging objects or numbers in order. So, wag po tayong malilito sa permutation and combination since parehas po silang nag-arrange ng objects, kaso itong permutation nagmamatter po yung order or yung sequence. So, if n and r are integers with 0 is less than or equal, then r that is less than or equal to n, then p and r is equals to n factorial over n minus r factorial. So here po, yung p and r or npr nagre-represent yung n nare-represent yung objects to be selected from r, objects to be selected from n at the time naman. Yung r po also called din po siya as r permutation, in which ayun nga order matters. So basic example po ng permutation. Ito po, in how many ways can we select 3 students from a group of 5 students to stand in a line for a picture? In how many ways can we arrange all 5 of these students in all line for a picture? So yung solution po natin, since 3 students lang po ang kailangan natin sa 5 estudyante para po ma-arrange, ang gagawin lang po natin is 5 times 4 times 3. So it is equals to 60 ways to select 3 students from group of 5 students to stand in a line for a picture. Kapag ang hinihingi naman po all 5 students para papilahin sa isang linya for a picture, bubuuin po natin yung equation, which is 5 times 4 times 3 times 2 times 1 equals to 120 ways to arrange for a picture. So next example po for the permutation, in how many ways can we arrange 2 of the 4 letters A, B, C, and D? So kung gusto po natin ilista, kung gusto po natin makita yung pattern, pwede po natin ilista hanggat kaya po natin. So meron po tayo dito, nakikita nyo, merong 12 ways na meron akong nalistang 12 ways dito: A, B, A, C, A, D, B, A, B, C, B, D, C, A, C, B, C, C, D, D, A, D, B, D, C. So kapag in-apply naman po natin yung formula, which is sa kabila na mas madali, n factorial over n minus r factorial, sa-substitute lang po natin yung 4 as n and 2 as r. So ayan po, 4pr equals 4 factorial over quantity of 4 minus 2 factorial. Tapos sinimplify lang po, and then 4 times 3 times 2 times 1 over 2 times 1, 24 over 2, or 12 ways. So take note po, if yung r value niya is 0, kahit kanino mo pa i-partner, kahit ilan pa po yung n, mas mataas pa po yung n sa kanya, kahit ano pa pong value ng n, wag lang negative, 1 lang po yung sagot. Ito po yung proof na kapag sinubstitute natin yung 0 as r, ito po yung formula, n factorial over n minus 0 factorial equals n factorial over n factorial equals to 1. So ito example, permutation of 69 and 0, 69 factorial over 69 minus 0. So 69 factorial over 69 factorial, cancel, magiging 1 na lang po yan. So next, example pa rin po sa permutation. So suppose that there are 8 runners in a race. The winner receives a gold medal, second place finisher receives a silver medal, and the third place finisher receives a bronze medal. How many different ways are there to award these medals if all possible outcomes of the race can occur and there are no ties? So, ang gagawin lang po natin dito is ititake lang po natin yung 8 runners. And siya po yung gagawin. Kukunin lang po natin yung tatlong numbers doon, which is permutation of 3. Permutation of 8 and 3. So, equals siya sa 8 times 7 times 6. Which titigil lang po tayo sa 6 since mababawasan lang po yung pwesto or yung place. So, ang possible ways lang po na makakuha ng award for these 8 runners ay 336 possible ways. So, yun po. Ayun, combination na po tayo. So, don't worry about sa permutation since ayan, this combination kasi i-discuss pa po siya further mamaya with restrictions na po. Diniscuss ko lang po yung basic concept ng permutation and combination. So, combination, ito naman po yung parang permutation nga sabi ko. Ngunit hindi po nagmamatter yung arrangement. Hindi po siya ma-arte sa arrangement. So, yan, a selection of a part of an object out of a set of objects which does not concern with order or arrangement. If n and r are integers with a 0 is less than or equal to r, that is less than or equal to n, then c and r is equals to n factorial over r factorial quantity of n minus r factorial. So, tulad po dito, namali lang po ako dito ng, hindi ko pa napalitan, pero C and R yan, yung here, C and R or B, C and R nga, represents the n object. So, parehas lang po siya ng concept kapag dinedenote na po or dinederive na po yung formula. So, next. Ito po, example ng combinations. So, nilagay ko po yung permutation para makita po natin yung difference nilang dalawa. So, una, ang question po dito is combinations of 3 letters, A, B, C taken 2 at a time. So, kahit combinations, ginamit ko pa rin po yung permutation. So, nilagay ko po yung N as 3 since 3 po yung letters, R since 2 ang gagamitin natin. I-substitute ko po sa bawat isa and then trinay ko na rin po ilista. So sa permutation, bibilangin pa rin po natin yung sequence kahit magdoble. Kaya 6 yung sagot. And sa combination naman, kaya 3 lang sagot kasi tatlong combination lang ang napili natin since bawal na dumoble. So ito po another example. How many different committees of 3 students can be formed from a group of 4 students? Set 1, 2, 3, 4. So, yun nga, ang gagawin natin muna, hanapin natin yung value ng n, which is equals to 4. Value ng r, which is equals to 3, kasi 3 naman ang hinahanap natin para makabuo ng isang group out of 4 students. So, kaya lilista natin, ayan po, 1, 2, 3. 2, 3, 4, 3, 4, 1, 1, 2, 4, 4 ways. So, kung i-apply natin yung formula ng combination, so, 4 factorial over 4 minus 3 factorial times 3 factorial. 4 factorial over 1 factorial times 3 factorial, kakancel na lang po. And then, 24 over 6 or 4 ways din. So, tapos na po tayo sa combination. Sa binomial coefficients naman and identities tayo. Chapter 6.4. Binomial coefficient. So, binomial coefficient is used to denote the number of possible ways to choose a subset of objects of a given numerosity from a larger set. It is so called because it can be used to write the coefficient of the expansion of a power of a binomial expressions such as a plus b squared. So, kung familiar po kayo dito sa formula na to, ito rin po yung ginamit natin kanina sa combination. So, related po sila. sa pagkuha ng binomial coefficients, related po silang dalawa. And this formula po na ginamit natin sa combination can be denoted as this po, which is para may parenthesis, tapos n, tapos k. Ang basa rin po dyan pwedeng n choose k. So ito na nga po, yung theory din po na nasa libro, which is binomial theorem. Yung binomial theorem po, nagbibigay po sa atin ng coefficients of the expansion of power of binomial expressions. So, kung familiar po kayo sa FOIL method, ginagamit siya pag-expand ng expression. Halimbawa, itong a plus b squared is equals to a plus b times a plus b. So, kung expand siya, kung gusto niyo siya expand, mag-FOIL method kayo kung mas madali sa inyo yun. So, a times a plus a times b plus b times a plus b times b equals, ito rin, a squared plus ab plus ab plus b squared. So, kapag kinumbine po ng like terms, ito po yung final, a squared plus 2ab plus b squared. So, pangalawang example po, a plus b cube is equals to a plus b times a plus b times a plus b, combining like terms then. So, kinumbine mo na yung dalawa, a times a times a times a plus a times b plus b times a plus b times b. So, yung nakuha nating kanina, nandito rin, tapos ita times pa natin sa isa. So, yun, kapag tinimes natin, a cubed plus a squared b plus 2a squared b plus 2ab squared plus ab squared plus b cubed. So, pag kinumbine po natin like terms dyan, ang magiging sagot naman po ay a cubed plus 3a squared b plus 3ab squared plus b cubed. So, yung binomial theorem po, meron po siyang formula na ino-offer. Ang nakita ko po sa libro, ito po, which is a plus b. So, power of n is equals to summation of k minus, equals to 0 raised to n. Tapos, ito pong n, itong familiar na sa combination na formula, n factorial over n minus k factorial times k factorial a minus n, a raised to n minus k b raised to k. So kung nalilito pa po kayo, ito lang po yung magmamatter dyan, pati ito pangkuha po ng coefficient to, ito naman pangkuha ng power ng isang variable. So kanina, since ginawa na rin natin tong a plus b squared, check natin kung parehas sila nung sagot if apply natin tong binomial theorem. Kasi hindi naman po natin kaya rin na also na i-add or halimbawa a plus b to the power of 5th. Mahirap na rin po yun if-FOIL method. So ito po mas parang dadali rin po siya. Pero hindi ko po sinasabing madali to. Mahirap din to kapag marami rin po yung terms. So, yan. Papakita ko lang po kapag sinubstitute natin. So, since yung ano po yung n natin, n po natin is 2. So, n po yung isa-substitute natin. I'm sorry, 2 yung isa-substitute natin sa n. Tapos, 2 factorial over 2 minus k factorial times 2 factorial a raised to 2 minus k b raised to k. So, ang ibig sabihin po nito, ito po yung sigma notation, or ito po yung pag-a-add po natin lahat ng terms hanggang sa magto po yung n natin. So, kung express po natin siya, gagamitin po natin yung formula. Magsisimula po tayo sa 0 since 0, k is equals to 0. Ayan po, ito po kung nakikita nyo sa baba sa may tabi ng equals, 2 factorial over 2 minus 0 factorial times 0 factorial. So kung mapapansin nyo, itong katabi na a raised to 2 minus 0, b raised to 0. 0 pa rin po yan kasi nasa first term pa rin po tayo. So plus na natin. Ganun ulit, gawin po natin uli yung 2 factorial over 2 minus k, which is gawin na po natin siyang 1. Substitute na natin siya as 1, pati rin po sa dito sa dito po sa may power, sa may variables. So plus ganun po ulit hanggang sa maging 2 siya, since 2 po ang pinaka-limit niya. So 2 kapag sinagot po natin yan, kapag kinalculator, pwede naman po natin i-calcu. So, kapag ito, magiging 1 siya, 1a squared, since 0 yan. Ito, b, raised to 0 is equals to 1, so hindi na siya mag-appear dito. So, ito naman, pangalawa, magiging 2, a raised to 2, or a squared minus 1 is equals to a na lang. B raised to 1, so magiging b yan. Plus 2 factorial yan, ito lang yung magmamatter, magiging 1 lang din yan. And dito magiging 0 na yung a, yung exponent ng a. So bale ang b din dito magiging squared. So ang final answer natin dyan, if ika-cancel na natin yung unnecessary na may exponent na 0, so a squared plus 2ab plus b squared na lang po. So check po natin kung tama po ba siya. Yan, tama po. Ginamit natin siya. So yung pangalawang example naman po, yun din, sinubstitute ko lang din po. Yun, mas marami na po siyang terms kaysa sa kanina, yung nauna. So, simula sa 0, 0, and then 0, 0 lahat. Itong first term. So, naging 1 na sa second term. Naging 2 na sa third term. Naging 3 na sa fourth term. So, yeah. Ito po yung sum niya. 1a cube plus, hindi pa po yan na so solve or nasi-simplify. A squared plus b plus, a squared b plus 3 factorial over 2 factorial a b squared plus 1a raised to 0 b cube. So kapag sinimplify po natin yan, cancel lang to, since 3 times 2 times 1, 2 times 1, cancel na lang po yung 2 times, parehas na 2 times 1, magiging 3 na lang po yan. So ayan po, bring down na lang. Yung 1a cube, bring down na lang din, hindi na po need mag-appear ng 1 since understandable naman po yan. So a squared, b1, b raised to 1, di na mag-appear yung 1, understandable. Tapos ganun din, same din sa kabila, 3ab, kaso, ang a yung wala yung squared, b, nasa b na yung squared niya, plus 1a raised to 0, which is 1. And there's 1 times 1 is 1, so hindi na mag-appear dito. B raised to cube, b cube. So next example, ayun. So paano naman po kapag iba, coefficient lang po yung hinahanap, and term lang po yung coefficient lang yung hinahanap talaga. So what is the coefficient of a raised to 12, b raised to 13, and the expansion of a plus b raised to 25th? So pwede natin i-apply yung binomial theorem na formula, which is this. Kaya nilagay ko pa rin dyan. Substitute lang yung 25 as n, and sisimula tayo sa 0. So since 25 ang n and factorial, then diretso ano ko na po yan, dinerecho substitute. N is 25, right? So, yung K natin, since B, kita po sa formula, yung B natin, yung exponent niya, K yung formula. So, 13 siya, understandable. Tapos, 25 minus 13 is equals to 12 factorial. Tapos, times 13 factorial, since K yan. So, A raised to 25 minus 13, B raised to 13 lang. So, bring down 25 factorial, 13 over 13 factorial times 12 factorial, 5,200,300. A raised to 12 and B raised to 13. So, ito po yung coefficient. Since coefficient lang po yung nahanap, so, ito po siya, itong 5 million. Next. Ito naman, another example, find the coefficient of the A raised to A cubed, B raised to 5 term in the expansion of 2A minus 3B raised to 8. So, since understandable naman po na 8 ang N natin, sinubstitute ko na po, ginamit ko ulit yung formula na to since ito po yung para sa coefficient. 8 factorial over 8 minus 5 factorial times 5 factorial. Ito, 2A raised to 8 minus 5 times negative 3B raised to 5. So, ayun, simplify ko. Minus ko po yung 8 sa 5, naging 3 factorial times 5 factorial. Tapos, ito rin, 8 minus 5, naging 3 factorial na lang. And then, ayan, the same. Tapos, ito sa baba, yan, factorial. 8 times 7 times 6 times 5 times 4 times hanggang 1. Meron po tayong 5 times 4 times 3 times 2 times 1. Yung yellow, na-cancel yan. Same ko yung kinancel. Tapos may na-notice ako ng pwede pa i-cancel, which is 6. Itong 3 times 2 times 1. So, bali 1 na lang dito. Ang gagawin na lang po natin, times na lang po natin ito. 8 times 7. So, 56 times 8. Yan, 2 raised to 3 is 8. And then, negative 3 raised to 5 is negative 243. So, pinag-times po yung tatlo. Since pwede po. And then, yung final answer, para po sa coefficient ng A cube, B raised to 5 is negative 108,864. So, ayun po. So, ito naman po tayo sa triangle na to. If kung mapapansin nyo, kung meron siyang pattern din, sabi nga ni ma'am kanina, mag-focus din tayo sa pattern na to. What if zero set has a 1 subset. So, kapag 0 siya, wala siyang value, pwede natin siyang may isang way lang tayo para kunin siya, which is 0 rin. So, magiging 1 siya, katumbas niya. So, what if a set has a what if yung given one set, so meron siyang 2 subsets. So, either kapag meron kang isa, hindi mo siya kukunin. Kapag meron kang isa, kukunin mo siya. So, tig-isang ways lang po yun. What if yung pangalawa naman, 2 sets siya, tapos meron po siyang 4 subsets. So, kapag meron kang 2, ang kukunin mo lang, may way na para kunin mo wala. So, isa yon. May way na para kunin mo tig-isa. So, dalawang way yon. May way para kunin mo sabay. So, isang way din yun. So, nakikita nyo yung pattern din dito sa baba. And then, yun, yung pangatlo, 3 set, meron siyang 8 subsets. So, yung una, kapag meron kang 3, pwede ka kumuha ng 0. Oh, hindi ko na-edit. So, I'm sorry. So, kapag 3 to itong pink, brown, tsaka medyo yellow na color. So, 3 yan. Hindi ko rin na-edit. So, sorry. So, yung ways na ito, 3, so bali 3, 1, 3 choose 1. So, meron kang 3 ways para kunin yun. 3 choose 2. Meron ka ring 3 ways para kunin siya. At saka 3 choose 3. Meron kang 1 way para kunin siya. So, ang malaga po itong nasa baba rin, since ang nabubupaw nating pattern dito is parang triangle, na kung saan kapag pinag-add po natin, kapag pinag-add po natin ito, so, halimbawa, 1 plus 1 is 2. Kung may background po kayo na itong tawag po dito is Pascal triangle. So, 1 plus 2 is equals to 3 and so on and so forth hanggang sa kaya i-construct or illustrate. So, ayun nga, ito po yung mas malinaw na kopya ng Pascal's triangle. Tsaka Pascal's identity na rin po. So, ano nga ba yung Pascal's identity? Isa po itong theory na kung saan si Pascal, si Blaise Pascal, pinopose niya tong formula na to, na kung saan ang n plus 1 choose k is equals to n choose k minus 1 plus n choose k. So, kapag i-derive natin siya dito, wait lang. So, ayun po. Halimbawa, ang kukunin po natin ay 7 choose 5. So, bale, ang gagawin po natin, gagamitin po natin tong formula na n choose k minus 1, which is, alam naman po natin ang 7 choose 5 ay kapag ang 7 nilagay dito, I'm sorry, 6 choose k minus 1. So, ito pong k, mag-value po, magiging 4 since minus 1. 6 po yung original niya. And then, 6 choose 5. Ito po yung n choose k. So, is equals to n plus 1 is k. Kinompute ko rin po to and same lang po rin sila ng value kapag in-apply. Wait. So, ito po, may checking po siya. So, 6 combination 4, 6 choose 4 plus 6 choose 5 is equals to 7 choose 5. So, ito po yung value. 6 choose 4, 15 is equals to 15. 6 choose 5 is equals to 6. And 7, so kapag pinag-add po yan, 21. So, dito rin po sa kabila, magiging 21 siya. So, meron rin pong isang formula ako nakita, hindi yung isa po na nauna sa galing siya sa libro, ito naman po nahanap ko rin po sa websites. So, since magkaiba po siya ng syntax or formula, pwede rin po itong i-consider na Pascal's identity, na kung saan kapag halimbawa ito po yung combinatorial proof niya. Kapag meron kang 5 applicants competing for 3 similar positions, ang isa-substitute mo lang 5 choose 3 is equals to, since meron kang n minus 1, 5 minus 1 is equals to 4, k minus 1 is 2, which is, 3 minus 1 is 2, plus n minus 1, 5 minus 1 is 4, and k, lalagay mo na lang doon. And yan, same lang din po siya ng makukuha. Same lang, equivalent lang din po siya. So, kung nalilito po kayo, ito po, may sentence po ako dito na ito nga, 5 applicants competing for 3 similar positions is equals to, kapag meron isang person na napili sa job at tinanggap niya, mababawasan yung position, at the same time mababawasan yung empleyado na mababawas na empleyado and mababawas na yung position. Pero pwede rin gagamitin natin yung sum rule if nag-refuse yung isang empleyado or nag-a-apply, hindi naman nababawasan yung position. So pinag-add silang dalawa. And then equivalent sila dito sa N choose K. So ayan. Sino nga ba si Blaise Pascal? So si Blaise Pascal po ay pinanganak noong June 19, 1623 and namatay siya noong August 19, 1662. So isa po siyang French mathematician, physicist, inventor, philosopher, and Catholic writer. So si Blaise Pascal din po ay tinuruan siya ng tatay niya na isang tax collector sa Rouen, France. Prodigy po siya since early age pa lang po, marami na rin po siyang nagawa. At 16, Pascal discovered an important result concerning conic sections. At 18, he designed a calculating machine which he built and sold. So kung alam niyo Pascaline, tama ba? Pascaline calculator. Along with Fermat, laid the foundations for modern theory of probability. So in this work, he made discoveries concerning what is now called Pascal's triangle.
Yep.
So ayun pa, share pa rin si Blaise Pascal. In this work, he made discoveries concerning what is now called Pascal's triangle. One night, distracted by a severe toothache, he sought comfort by studying the mathematical properties of cycloid. Miraculously, his pains have subsided, which he took a sign of divine approval of study of mathematics. So, dapat po talaga, titigil na po siya sa pag-aaral ng mathematics. And then, one day, one night nga, na-distract po siya dahil sa toothache. And then, ayun, so, na-curious siya, pinag-aralan niya. And then, kinonsider niya na ito na yung sign na para magpatuloy sa pag-aaral ulit ng mathematics. So, in Paris, on 19th of August, 1662, Pascal went to, into convulsion and received extreme unction. So, he died next morning, his last words being, "May God never abandon me," and was buried on the cemetery of Saint-Étienne-du-Mont. So, I believe 39 years old lang po yung siya nung namatay. So, sayang. So, yun po. About more on Pascal's triangle. Ayun nga, named after mathematician Blaise Pascal. Pascal's identity shows that when two adjacent binomial coefficient in this triangle are added, the binomial coefficient on the next row between these two coefficients is produced. So Pascal's triangle has a long and ancient history predating Pascal by many centuries. So if titingin po kayo sa book or ebook na sinend ni Ma'am, marami pong gumamit or marami ring may same concept kay Pascal. Sa yung triangle ni Pascal. So marami ring nagki-claim na sa kanila yon. Sa iba't ibang lugar, iba-iba yung nag-claim. So, pero po si Blaise Pascal po talaga yung nagpasikat or sa kanya sumikat itong triangle na to or itong concept na to. So, next po na mathematician natin ay si Alexandre Théophile van der Monde, 1735 to 1796. So, isa po siyang sickly child. Physician po yung father niya na nag-direct po sa kanya para sa magkaroon ng career sa music. However, na-develop po yung interest niya sa mathematics. He complete mathematical work consists of 4 papers published in 1771 to 1772. So, these papers include fundamental contributions on the roots of equations, on the theory of determinants, and the Knight's tour problem. Van der Monde interest in mathematics lasted for only 2 years. So hindi siya katulad ni Pascal na matagal talaga, bata pa lang. Masaya na siya sa mathematics. Ito na-develop niya sa kanya talaga and nag-last lang ng 2 years. Na kasi na-interest din siya sa politics at saka nag-join din siya sa French Revolution and holding several different positions in government. So, meron rin po siyang pinopost, which is Vandermont's identity. Isa rin po itong concept na related din po sa triangle ni Pascal since binomial coefficient is malawak din po talagang concept and topic. So, kanya po, let M and R be non-negative integers with R not exceeding either M or N. Then, pwede niya po, ito po yung pinapost niyang formula. N plus N, choose R, is equals to summation of R, K minus 0, quantity of M, choose R minus K, times N minus, N choose K. So, trinay ko rin po itong gamitin as an example. May example po ako dito. So, trinay ko po yung 3 plus 4 since yun nga ang formula is n plus n. So, 3 plus 4 over 2. So, is equals to summation of k equals to 0 which is 2 also. So, yung solution po niyan, ganun din katulad po sa una, pinag-add po yung different quantities neto. So, kung makikita niyo sinubstitute ko yung M ko ay 3. So, yung R din, sinubstitute ko with K na wala pang value. And then, kabilang quantity, 4 choose 0 which is yung K nga 0 and then yung N, siya po yung 4. Plus, ganun din, kinopy ko lang, then ang binago ko yung 0 which is ginawa kong 1, plus binago ko lang din ulit hanggang maging 2. So kapag binalyo po natin siya or kapag sinimplify, 3 times 1, yan po yung sagot ng dalawa. 3 times 4, yan po yung sagot ng dalawa. 1 times 6, yan po sagot na itong pangatlong term. Lahat-lahat po sagot 21. So, kapag kinumpute po natin tong 3 plus 4 over 2, choose 2. So, bali magiging 7 choose 2. Ang sagot niya po ay 21. So, yun po yung proof na pwede natin, tama po yung identity or proposal nito ni Vandermoont sa binomial coefficient. So, I believe yun lang po yung report para sa part ko. And calling for the next reporter, Miss Monica.
Good morning. Good morning sa inyong lahat. Ako si Monica, ako naman yung mag-report for generalized permutations and combinations as well as generated permutations and combinations. So, next slide. So, in generalized permutations and combinations, they're going to solve counting problems where elements can be used more than once, including indistinguishable elements and problems involving counting ways. Distinguishable elements can be placed in boxes. So, tatalakayin natin is permutation with repetition, combinations with repetition, as well as yung ways na pwede natin ilagay yung mga things sa boxes, either distinguishable or indistinguishable yung elements or objects. Pero first of all, sabihin ko muna sa inyo yung meaning na distinguishable objects, which means na identify yung mga objects or boxes sa isa't isa, na-differentiate mo ba, kumbaga. Pero pag indistinguishable, sabihin identical. So, di mo ma-differentiate sila from one another. Ayun, so basically, hindi mo rin alam kung paano mo talaga pick yung, kung lalagay ka ng possible combinations pertaining to those. So, proceed tayo sa first topic natin, which is permutations with repetitions. Next slide, please. Ayan, permutations with repetitions. Ang first theorem natin is the number of R permutations of a set of n objects with repetition allowed is n raised to R. So, considering na kapag meron kang string na kung saan may 4 kang slots and you have 4 choices, hindi imbes na mapili mo na yung isang letter is ibig sabihin hindi mo na siya gagamitin pa. Permutations with repetitions kasi yung elements, yung tawag dito, yung mismong pagpipilian mo is yun nga is pwede siyang ma-repeat hanggang sa wala ka ng slot left. So there are n ways to select an element of a set for each of the R positions in the R permutation where repetition is allowed, because for each choice all n objects are available. Hence, by the product rule, there are n R permutations when repetition is allowed. So, next slide please. Patalakan natin yung first problem natin, which is how many 3-lettered words can be formed from letters A, B, C, D, E, G, H if repeats are allowed? So in this problem, 3-lettered words yung isa-solve natin dito, and yung choices natin is A, B, C, D, E, G, and H with repeats allowed. Di sabihin yung combinations pwede A, B, A, A, C, A, D, A, yung pwede umulit yung mga mismo letters. So, in solution natin dito, we're going to apply the theorem 1, which is n raised to R. So, yun nga, 7, wait lang. Which is yung answer dito is 343. So, 343 repeats are allowed. Next po. Ayun. From the set of first 10 natural numbers, you're asked to make a 4-digit number. How many different permutations are possible? So, ang solution dito is P10. Yung N natin is 10 and R natin is 4. So, 10 raised to 4 is equal to 10,000. So, ang sagot natin is 10,000 permutations are possible. Next po. Combinations with repetition. So, andito naman sa theorem number 2, there are Cn plus R minus 1 R is equal to Cn plus R minus 1 N minus 1 or combinations from a set with n elements when repetition of elements is allowed. Each R combination of a set with n elements when repetition is allowed can be represented by n minus 1 bars and R stars. So, ay yung mismong big sabihin nito, n minus 1, kasi the order is like, hindi siya importante. Kaya may n minus 1. And since repeated elements nga, yung R, pwede mo siyang ilagay sa kahit saan na slot dun sa n minus 1 na yan. So, next slide please. So, the problem is, in an ice cream shop, there are 5 flavors available: banana, chocolate, lemon, strawberry, and vanilla. We ordered 3 scoops ng ice cream na yan. So, how many variations will there be? So, wala tayong pang-order. Kasi, for example, may 2 vanilla, 1 strawberry, or may 1 lemon, 2 vanilla. So, ang solution is R plus n minus 1 factorial over R factorial, parentheses n minus 1, then factorial. So, kinuha natin yung R dito, which is 5, kasi we have 5 choices, then plus 3 minus 1, 3 na scoops minus 1, then factorial over 5 factorial, 3 minus 1 factorial is equal to 7 factorial, 5 over 5 factorial 2 factorial, which is equal to 5,040 divided by 120 times 2 is 240. So, bale, ang sagot is 21. Next, permutation with indistinguishable objects. So, bago natin talakayan natin, alamin muna natin yung problem, which is how many different strings can be made by reordering the letters of the word success. So, the number of different permutations of n objects where there are n subscript 1 indistinguishable objects of types 1 and 2 indistinguishable objects of type 2 and nk indistinguishable objects of type k is n factorial over n subscript 1 factorial and subscript 2 factorial over n subscript k factorial. Next slide, please. So, ayun, to account the theorem number 3, ang pinaka-solution natin is to multiply yung C7, 3, C4, 2, C2, 1, then C11. So, from there, nakita nyo po sa solution is ang 7 factorial over 3 factorial, 4 factorial, and then yung 4 factorial na carry over dun sa next natin, which is 4 factorial, 2 factorial, 2 factorial, then 2 factorial over 1 factorial, 1 factorial, multiplied by 1 factorial over 1 factorial and 0 factorial. And kung tatanungin nyo kung bakit ito yung values natin, is because sa word na success, we have like 7 letters, which is tatlo doon is letter S. Na-account siya dun sa C73, then C42, which means dalawa yung C. And since nakuha na yung tatlong slots from the 7 earlier, ayun, bale, dalawa na lang siya. Then C21, kasi isa lang yung letter U, and C11 dahil isa lang yung letter E. Bale, nababawas yung letter N value kasi yung sa pinakauna, like, diba, tatlo. Tas, bale, 4 na lang. Bale, nag-subtract yung value niya kasi nakuha na nung previous yung spot na yon. So, if you add them all, kinancel, papansin nyo, naging 7 factorial over 3 factorial, 2 factorial, 1 factorial, 1 factorial kasi na-cancel na yung 4 factorial dito sa baba. Then, 2 factorial saka yung 1 factorial dito. So, bale, if you solve it, magiging 420 yung sagot. Next po. Distributing objects into boxes. So, may 4 na types tayong tatalakayin dito, which is distinguishable objects and distinguishable boxes, indistinguishable objects and distinguishable boxes, distinguishable objects and indistinguishable boxes, saka parehas objects and boxes na indistinguishable. So, una po tayo, which is distinguishable objects and distinguishable boxes. The number of ways to distribute and distinguishable objects into k distinguishable boxes. Next slide. So that n objects are placed into box is equal to n factorial over, well, kung mapapansin nyo, may same pattern din siya na ginamit na formula dun sa last. So, the problem is, how many ways are there to distribute 5 card poker hands from 52 cards to each of the 3 players? So, ang solution natin dito is player, next slide. Thank you. So, ang solution dito is player 1 has 52 cards. Then, since kailangan may 5 na card siya, kaya sa player 2, may 47 na lang, and sa player 3, 42 na lang. Kung mapapansin nyo, yung parenthesis dyan, dapat mas malaki, pero, well, nabitin siya. So, anyway, 52 factorial over 47 factorial, 5 factorial, times 47 factorial over 42 factorial 5 factorial times 42 factorial over 37 factorial 5 factorial. And kapag kinancel natin yung 47 and yung 42, ang magiging solution is 52 factorial over 5 factorial, 5 factorial, 5 factorial, and 37 factorial. And kung mapapansin nyo, binold ko na yung 52 factorial over 5 factorial, 5 factorial, 5 factorial, and 37 factorial is because yung pinaka-decimal number niya is too big. Kaya, kung makikita nyo sa gilid is 3.3913223 e raised to 18, which is the scientific notation po nung mismong answer kapag inano mo siya sa scientific calculator.
Correct.
So, in the distinguishable objects and distinguishable boxes, ang problem is, next na po, is how many ways are there to distribute 10 identical tokens into bins labeled from 1 to 5. So, kung mapapansin nyo, yung sinabi ko kanina definition ng distinguishable and indistinguishable, diba? Since yung objects dito indistinguishable, which are the tokens, kaya well, identical siya, di mo siya ma-differentiate. Unlike distinguishable, yung beans, tignan niya sa problem, which is naka-label siya from 1 to 5. So, the solution is n plus k minus 1 factorial over k factorial parenthesis n minus 1 then factorial. So, ang ginawa ko dito, ang n natin is 5 and k natin is 10. So, 5 plus 10 minus 1 is 14 over 10. Parang medyo shortcut ko na tong part na to. Bale, 14 factorial over 10 factorial, 4 factorial. Kasi n minus 1, 5 minus 1 is 4. So, n yung pinakasagot. Kasi, nung sinolve ko siya, yung sagot niya is naka-scientific notation. So, hindi ko na siya masyadong binother. Ayan yung pinaka-final na answer. So, next.
Si Mika may taas ng kamay?
Yes, may question.
Time na po.
Ay,
Oh.
ayan yung ate reminder. Ay, oo nga, alas 10 na. Okay. Teka
Opo.
lang, yung topic nyo, mahaba pa ba to?
Ano po, nasa kalagitnaan na po tayo ng 6.5 and then meron pa po 6.6 which is, yun nga po.
Okay.
Medyo mahaba po.
Okay, sige. O sige, tuloy na lang natin next, yung next meeting. Ayan. So,
Sige po.
okay. So, pasensya na. Tapos, dun
Okay.
sa ating topic, ang kinover po nila ay, yung pinaka-main topic natin ay counting, no? So, chapter 6, counting para sa group 3, which is ilalagay dun sa inyong sa ating attendance form. So, chapter 6 po yung kino-cover ng group 3, which is counting, no? So, hopefully, next meeting, ang next na group ay group 4, chapter 7 and 8, no? So, mag-ready lang yung group 4. Ayan. Pero, I think, kung mahaba-haba sila, baka kalahati ang magamit ng group 4 next meeting, no? Okay. So, yun po yung yung ating discussion for today. Salamat group 3 for covering the chapters. Again, ulitin ko lang po, no? Kasi we're delving into deeper data structure and algorithms, no? Ito nga, nag-aano na tayo sa counting, factorial, no? So, the best way po para maintindihan natin yung data structure at saka algorithm and data structure. Just look for the pattern, no? So, kung mapapansin nyo naman, no, laging sinasabi, no, nauulit, no, pi factorial. So, look at these patterns and as you look into the pattern, you'll be best, no? You'll be best to know yung natin, yung mga algorithm na dinidiscuss dito. And you would appreciate, kasi nung araw ginawa na yan eh, meron na ngang namatay, di ba? Si Blaise Pascal. De, joke lang. Yun naman sa kanya eh, ibang reason naman yun. But there are a lot of people who loves math, no? Hindi lang si Blaise Pascal. And ayan, ini-hand down sa atin, no? Best way, no? Best way to understand mathematics, applied mathematics dito sa atin is data structure, no? So lahat naman can be explained in what, no? Sabi nga yung ating Diyos ay isang mathematician, no? Alam niya na dapat kung may umaga, may gabi, no? Kung ang 1 plus 1 is equal to 2, pwede niyang gawin ng iba-ibang combination. Depende kung anong logic ang ginamit niya, no? So, ayan. So, maraming naka-appreciate, no? Marami tayong kinote na mga mathematician dyan, no? Sinasummarize ko lang yung natin, no? But, again, the best way to learn is to find the pattern, no? Once you see the pattern, hindi na kayo mahihirapang maintindihan itong ating pinapasok na mga algorithms sa discrete, no? Advanced discrete. Okay, thank you. Thank you sa group 3. At babalik sila next meeting. Hopefully, susundan sila ni group 4. Okay? So, may question po ba kayo dun sa ating diniscuss? Pakita ko lang yung ating attendance. So, we started like 20 plus. And, right now, so may iba na wala, no? Napuputol, bumabalik, no? Nasa 31 tayo. Ayan. Including myself, so 30. So, kanina umabot na ng 34. Nasaan ba si Rachel? Ano nga yung official na number natin dito? We are at 30. Ilan pa yung kulang natin?
37 po lahat, ma'am.
So 37. So, may pitong, may pitong
wala.
on and off. Yan. Okay.
Yes po.
Alright. Okay. Salamat ng marami, everyone. Ayan. Kung wala na po kayong question, please don't forget to fill up the form, the attendance form in your GC. No? Again, ang nakalagay pong topic, tayo ay nasa chapter 6 and it is counting. No? Ayan. Okay. Thank you. So, kung wala na po kayong tanong, sige po, balik tayo ulit next meeting. Thank you!
Thank you po.
Thank you for coming. Ayan.
Thank you po.
Okay. Alright. Okay, i-end ko na yung ating video.